Okay, so today we will start a new topic. I think we we went over the loopings. It was mainly just showing you the syntax for looping structures. I'm confident that you all saw loops in Python, and it's just a refresher with new syntax. So that's those lectures. That's all we're going to spend on looping structures. So from today on, like if you were kind of like, man, this class is like too vanilla, it's too easy, right? So it'll be more interesting because we take deep dive into how memory and code works. So if there's something that you need to learn about memory and code, is that every line of code you write eventually ends up in memory, because that's where programs run. They run on the computer's memory. So when I had gotten my first job in the 90s, some guys, they were talking about functions, developers, more experienced than me, right? And they were like talking about function parameters, and they were like, well, is that function passing passing parameters by value or by reference? And I was just kind of like, okay, what are they talking about? I was kind of confused. And then they were talking about like checking in code to the main repository. Git didn't exist back then. And make sure that you write the code and then you check it in. And I was like, I was kind of lost. I didn't know what they were talking about. So I asked them about the code, like, what do you mean check in, check out? And they explained the process to me. So mainly like what you all are doing in Git, where you write code and then you submit code. And I didn't ask them about function parameters. I went home and then I was like researching, like, what are they talking about, right? Maybe the professor did cover it. Maybe I spaced out during those lectures or that lecture. But I will take a deep dive into functions and function parameters and how functions work, so that you don't have to go through what I went. And this is going to be about a 2 week trip where you're going to like understand how functions are loaded onto memory, what a function parameter that's called by value is, and what a function parameter that's called by references. And you won't be like tripping over those concepts like I did. I'm not blaming my professors. Maybe it was me, right? Like half the time I was sleeping in class because I had to work full time and then go to school full time. So, but I wish they would have covered it more, right? Because maybe then it would have sunk in. So we'll cover it in detail to make sure that you are aware of code and memory. It's very important. It'll help you select better algorithms when you are out there working. Like, should I pick, what kind of algorithm should I pick for this code, right? So if you know more about how memory works and how code works, then you won't pick slow algorithms, right? I see someone's not muted and talking, so now I gotta find that person. So let me mute all. I guess I'll just mute all. Mute all. Yeah. Okay. Okay, so let's get started with deep dive into functions, right? So let me share my screen here. And let's open. We've been working with functions, and we know there's two types of functions. A void function, it doesn't return a value, and a value return function, that one returns a value. But for now, we're gonna talk about like function parameters, right? I'm not going to waste too much time in explaining what a void and value return function is. You should have a good idea of what that is. We'll look at function parameters. But before we do that, like, why do we use functions, right? So it's mainly to take a divide and conquer approach to programs. And as the software engineering method or software engineering matured, then like testing became more came to the forefront, right? As like program, I'm not saying that they didn't test in the 70s, but like the testing utilities matured and developed and progressed as the decades went by, right? To where like now, like you can write code and they're like automated and makes life easier for programmers, and always trying to like write code with fewer bugs, right? So if we go here, right, so break function can help us break problem into smaller pieces, and then we can code and we can solve or we can test with specific tests, right? And then it promotes code reuse, right? So that's why functions are good. We don't want to write like a lot of code in a scripting page or in one page, and then it's kind of like, well, how do we test that code, right? Maybe I should rephrase that. How do we successfully test that code in a way that is repeatable as our code base grows, right? So maybe you can test code in functions if you have one or two functions. And the easiest way would be, well, I'm just going to run my program, and if it gives me output that I know it should give me, then my program works. But that's not scalable. Like if you have a program with 1 million lines of code, you can't do that. Like there's no way you can test all the routes and paths for that program. So that's why testing is important. And if you have functions that are used a lot throughout your program, then it's better like to put that code in a function, and then you can just call that function instead of writing 10 lines of code here and then the same 10 lines of code over here and then the same 10 lines of code over here. And then when something changes and you have to go find all the pieces, all the code pages where you wrote that code, right? And that can lead to a lot of issues. So that's why functions are very useful nowadays, right? So, but I want to start with function parameters, and then we'll cover like function scope and other function topics. So let me go here and just briefly like refresh your memory as to how functions are in memory, right? So we go here. Functions on stack memory. So assuming we're not going to have variables, right? I'm just going to put like a main function here, and then we have this, and then we have return 0, and we'll just go with that. And we know that we have stack memory, and I've always been saying, well, you know, main gets some block of memory, and parameters go here, and then function variables go here too in this block of memory. The return value, right? So that's what happens when a function runs, right? Like it gets a block of memory, and then like it needs room for parameters. It needs rooms for its local variables, meaning like if we had a variable like int num equals 0, right? And then the return value, right? So it needs memory for that piece. So that's what's happening when a program runs. But now let's investigate, well, what happens to the parameters, right? So let's take a deep dive into parameters and investigate, well, what happens to parameters when when we're like sending values in and using those values and returning those values, what happens, right? So let me go and write some code to start investigating that. So we go here. So why are we covering this, right? So in computer science, like, yeah, we want to teach you how to program, but then we also want to teach you how things work, right? So in this case, things is how code and memory work together, right? So that's why we're covering this piece, and it is one of the objectives for this course. So we go here to SRC, examples, and we go to functions. And we can go here. I'm gonna go here into this one, val and reference parameters, because that's what I'm talking about right now. I'll go back to void functions, but I think this is more important. So we have some code, and let me see here. We have void, right? Doesn't return a value, and we'll say ref val params. We'll say that, and actually, let me break it down into two separate functions. We'll say value params, and we'll have one parameter. Then we go here, and let's write some code. Oops. Open, close, and we go here, and let me make sure I include val ref. No, I have my driving glasses on, so I'm having a hard time seeing the screen. Let me put on my computer glasses. Oh, I can see the screen. Okay. So okay, so let's just do something simple here. We'll say num equals 20. That's it. That's all we're doing here. Now let's go write a test case. Okay, include val ref and then test case. Okay, and we'll create num equals 5. Afterward, we call our function, which is value params, and then we pass in that variable. And then we need to say, well, what are we trying to test, right? So let's see. Well, we're going to say, okay, require that num equals what, right? So that's the question here, like, what should num be equal to? So we trace this code, we go num equals 5, value params, let's send num into here. What happens in here? We set num equals 20, we exit, so now the question is, should the value here be number 5 or should it be number 20? And I'll take some answers from the chat, or you can just say, right, best of 3, right? So if 2 say 5, then we'll do 5. If 2 say 20, then we'll do 20 here, and we'll run the test case. And then we'll diagram to see what's going on, okay? Okay, so 20, 5, 5, 20. Okay, one more. I need one more, right? So one more vote, because it's 2-2 right now. So if somebody else wants to chime in, 5, okay. Okay, and let me see here, Quentin, okay. So 5, okay. And then we run the test case. So run in terminal. While that runs, I think somebody got here real quick, so just let me tell him that I'm not available. You are? Oh, déjame. ¿Eh? Oh, okay. Vale. I'm in the class. Okay, that's my brother. I told him I can't talk to him right now. Okay. Okay, so negative s, right? So we have 5, right? So the value 5. And Quentin's correct, right? We're using a scope variable. So this one right here is a function local variable. You'll hear it mentioned as like function variable or local variable. So anytime you hear that term, it's talking about a variable like this, and this variable's lifespan is line 11. It's alive here on this line too, and all the way up to here. But what we are interested in, well, what happens? What happens when we say value params num? What happens? Because this piece of code didn't change the value. Although, like, to our eyes, it might seem like, hey, wait a minute, like, well, this is num here, and then this is num, and then I send num, but like, num equals 20 didn't like affect anything. So the correct answer is, as Quentin stated, like, it's a scope variable, but it'll make more sense when we put a picture and then go through what's going on. Okay, so function value parameter, and let me copy the code. We'll assume it's main, not a test case. Okay, so I'll say main here, and then I'll copy the code into this main block here. It's the same thing, like, but using main makes the diagram simpler. If we use test cases, the diagram gets more complicated, and I don't want to do that. Okay, so we go here, and we're just interested in this. So let's copy it here, and then so that you can have reference when you review notes, then we'll also copy the code for this one here. We'll say, well, value params looks like this. That way, when you read the code and you get here value params, you're not asking, well, what does value params do, right? So let me see if you think yeah. So that's what value params is. Now we can diagram, and we're like, okay, so what happens? So let's go here and stack. All programs always have the heap or the free store available. We're not using it yet. We'll start using it in about a week. All right, so this one, it's not in use. So I'll put not in use for this example. Okay, so let's draw some lines here. And then main gets loaded. So main gets loaded onto memory. So it's in memory. And then we need to diagram its variables. So we have num, so 5 goes there. And then this is called. So value params is called. So we'll denote that like this, right? So if it's called, that means it is also loaded onto memory. Value params in memory. And what does value params have? Well, it doesn't have any function local variables, right? Meaning we didn't declare new variables, but it has a parameter. And if it has a parameter, well, it needs a block of memory somewhere. So we're just going to say, well, that one's here. So as this piece is happening, this value 5 is copied. to this block of memory. So we have your name is num, your name is num, but they are in two different memory addresses, kind of like two John Smiths or Mary Smiths in two different addresses with the same name, but they are two different couples, right? So that's what's happening here. So then we say num equals 20. And when we say num equals 20, we're saying you change from 5 to 20. And now the question is, how long does num live? Like in memory, how long? Well, it's only alive while, my cursor, while this value params right here is executing. Once it stops executing and it finishes, then it starts exiting, right? So meaning it's removed from memory. From stack memory. And then this piece here, all this block here, is available for our program to reuse. So even though, like we say, it's removed from memory, the memory is not deleted. It's just freed, and this block of memory is free for our program to use. In this case, we're here, and main doesn't have anything else to do, so main will also be removed from memory, and then the memory is given back to the operating system. So that's what happens with a function value parameter. Two different variables. So this num lives, this num lives, this this num here lives in the main scope, and this num here lives in the value param scope, right? So two different scopes, and that's why our test case, let me see here. Yeah, I drew it correctly. So we go back to the code. That's why this code doesn't affect this variable. They're two different variables, okay? So please make sure that you understand this concept. You'll see it in quizzes, you'll see it in exams, midterm and final, because you need to understand what a value parameter is. It's also called a copy parameter. And the copy is because, as I showed you, right, the value is copied into another memory address. So that's why that's the case. Questions here?